rule is going on right there? Product rule. Good. And the fact that you guys are recognizing the different rules, that's awesome at this point. Okay? So we're going to keep the first, take the derivative of the second. What's the derivative of y? dy dx. Good. Plus, we're going to keep the second, but I always keep the coefficient. Okay? The coefficient stays. All right? So keep the second. Derivative of the first would be what? dx dx. And we don't switch to the dt's until we're in a related rates problem. So until you're in one of the word problems. Okay? Which we've been working really hard on this week. Don't just skip them. Oh, by the way, those are going to be worth more on the test than the other questions. So you don't just skip them. Okay? Mr. Lepis and I decided yesterday. Yay. Okay? But who knows? Maybe I'll forget to take them down. Okay. Be careful though on the posters, because they're not all worded the same way the one on the test would be. So you got to really watch the poster. So some of you may need to add to your posters because we don't have a problem. Okay. All right. So what's the derivative of 4x? 4 dx dx, right? Which I don't write down the dx dx. Plus, what's the derivative of y squared? 2y dy dx. And really that dy dx, you guys, that's your chain rule, right? Because I took the derivative by moving it in front, and then I took the derivative of the y. Okay, so the chain rule's acting there, but we know implicit we just do the dy dx after everything. All right, so we got to get the dy dx's together and everything else on the other side. So how do we move the 3y over? Subtract it. And then how do I move the 2y dy dx over? Subtract it again. So dy dx minus 2y dy dx. All right, what can I do with this dy dx? Take it out of it, as better known as factoring. Okay, so what's left behind? Good, equals 4 minus 3y. All right, what are we going to do with this? Divide it. So dy dx equals 4 minus 3y over 3x minus 2y. Is that one of our choices? Not that one. Oh, it's not one of our choices right now, right? Okay, so looking at what it's not F. One of those is going to work, okay? But this is a trick they like to do. Could I factor a negative out? Okay, so look at what happens when you factor the negative. And this is the way sometimes multiple choice goes. And it's unfortunate, but we have to be prepared. I didn't factor out very well, did I? We have to be prepared for this to happen. Okay? So now that I've got that factored out, that goes positive. Couldn't I write it in the other order? 3y minus 4 over 2y minus 3x. Is that a choice? Yeah. Yeah, it's this one right here, isn't it? So sometimes in calculus and in math, we have to manipulate it to get to the answer. Okay, so we had to do extra algebra.
So you brought out a negative, so the 4 turns into negative?
Yeah, because I factored it. I took a negative out of the whole thing. Okay, does that make sense? And the only reason we did it was to get to our multiple choice answer. Had it been an open-ended question, I would have just left it. Okay, but we had to get to the multiple choice they told us that they had. Okay, all right. Caesar, you get to pick the next one. Oh, Alvarez, sorry. I'm going to go in seat order. Number 10? Sure. Okay. Oh boy, I can't see him now. That's good. Apparently I didn't blow those up very good. Alright, I'll see if I can find number 10 on my screen here. Alright. You guys can be following along on the computer, right? Okay, so we had to find, it says that it's f of x equals 1 plus x over 20 to the 5th power. And they want us to find the second derivative evaluated at 40. Okay, so we got to start by finding the first derivative. Think about this, though, as 1 plus 1/20th x. So it isn't a quotient rule. It's actually a fairly basic function. It's just got a funky coefficient. So my first derivative says I take this and bring it where? Front. So we've got 5 times 1 plus 1 over 20x to the 4th power. And then I have to do the chain rule, the inside. So what's the derivative of the inside?
0. I mean 20x. 1 over 20x.
1 over 20, right? So 1/20th. Before I take a second derivative, could I simplify that? Yeah, 5 into 20, how many times? 4. So I really have 1/4 times 1 plus 1 over 20x to the 4th power. Now let's take a second derivative. So I'm going to take this 4, and where does it go? To the front. 4 over 4 is going to be what? 1. I'm going to write the 1. Normally I wouldn't, but I'm going to write the 1. And then I keep what's on the inside to the what power? 3rd. And then I still have to do the chain rule again. What's the chain rule going to give me again? 1 over 20. Okay, I don't really need to rewrite it. I am going to go ahead and plug in my 40 now. Okay, so f double prime of 40 equals, I'm going to drop the 1. 1 plus 1/20th times 40 cubed times 1 over 20. All right, so how many times does 20 go into 40? 2. So what do I have on the inside of that thing? 3 cubed times 1/20th. What's 3 cubed?
8.
No. 27 over 20, right? Which I don't think that reduces, does it? No. So if you look at your answers, it's got to be 1 point something, doesn't it? It's probably B. If we gave you that, either we'd switch these to fractions, if you didn't have a calculator on it, or it'd be on a calculator portion. And I don't know if we've decided if we're going to do calculator or not on this one. I know it says calculator, but we may switch it to not. I don't know. We'll make the decision by Monday and let you know. Okay? All right, we good with 10?
No, I'm saying, how'd you get 1?
How did I get 1 here? So I brought the 4 in front. 4 times 1/4 is 1. Right? Because I have to bring the 4 out here. 4 times 1/4 would cross out. Okay? We good, Caesar?
Yeah.
All right, Zoe, what do you want?
Number 3, please.
Number 3? All right, so apparently all of my slides are like that. That's nice.
That's good.
Okay, yeah. So, f of x equals x squared cosine 2x. They want me to find the derivative of it. What rule do we need? Product rule. And this one's in there because there's a chain rule embedded in it. Okay? So you're probably going to see at least one time on the test where you have to do a product rule and there's a chain rule embedded. If it's not this problem, it will be something similar. Okay? So, keep the first. What's the derivative of cosine? Negative sine of 2x. And then I've got to do the chain rule piece on this. What's the derivative of 2x? 2. And notice where I put the parentheses. Okay, I probably could have left myself some space and put that 2 up front. But you don't want to make it look like this 2 is inside the trig. Okay? Plus, so that was keep the first derivative of the second, keep the second. So the cosine 2x. What's the derivative of the first? 2x. Let's see. Is that one of our choices? Close, close. We could probably guess it from there, right?
Yeah.
Or we could probably recognize it. So they just rearranged it. The good news is they didn't factor out a 2x. Because sometimes they will do that to you. So this one was B, right?
D.
It was a D?
Mm-hmm.
Oh, maybe it was typed in a different order or something. Oh, is it
They
written
flipped
Oh,
it.
they flipped these?
Yeah.
Okay. Yeah.
Why did you only have to do the chain rule for the first one?
Because the chain rule only was this piece here where there's a function inside of a function. Only where I take the derivative of cosine do I do the chain rule. Okay? All right, let's see. DeLorean, what do you want to see?
Number 11.
Number 11. All right, so number 11, which I still can't read. Okay, which is the slope of the line tangent to, and I say it's y squared plus xy minus x squared equals 11. So what kind of differentiation do we need?
Implicit.
You have to do implicit, right? Because we've got the x's and the y's kind of together. So whenever we see the y, we write dy dx. So what's the derivative of y squared? Good. And then what rule do I need here? Product rule. So keep the first. What's the derivative of the second? Plus keep the second, which is y. What's the derivative of the first? dx dx. Okay, now I've got to do the derivative of this thing. What's the derivative of negative x squared? Dx dx. What's the derivative of 11? That's where people actually mess this one up, is they'll keep the 11. Yeah. Okay, so be careful. Don't let that happen to you. All right, let's see what we can do here. It looks like I need to take and move these two to the other side. So how do we move the y? Subtract it. And how do I move the x? Do you notice how I wrote them where the positive one is first? Okay. This one we've got to plug in, but typically when we see, if it's just going to be algebraic answer, you're going to see the positive one written first. Okay, so I automatically will do that. In the same step, couldn't I factor this out? Yeah, so rather than writing all that work again, so I'm going to factor out what's left behind. Now, I could probably plug in right here. In fact, I could have probably plugged in without factoring out, but I'm going to go ahead and move it. So we practice that, because if I don't give you one where you plug in the number, you're going to need to practice this step. So 2y plus x. All right, it looks like we're plugging in a 2, 3. So what I'm going to put 2 in for x and 3 in for y. So 2 times 3 minus, I'm sorry, 2 times 2. It's 2 for x, 3 for y. Minus 3 over 2 times 3 plus 2. What's 2 times 2? Minus 3? 1. All right, look at your answers. What does it have to be? It has to be C. It's 1/8, right? 2 times 3 is 6 plus 2 is 8, so 1/8. All right, Gonzalo, you get the next pick. 15? Okay. All right, so 15, the second derivative of f of x equals 2x plus 3 to the 4th power. All right, so it looks like I have what rule that I definitely need to do here? Chain rule, right? Because I've got an outer function and an inner function. What's my outer function? The 4th power, okay? So, and it said I had to go to the second derivative. So I need to take this and bring it where? To the front. So we've got 4 times 2x plus 3 to the third. And then the chain rule says take the derivative of the inside, which is 2. Before I take the next derivative, I'm going to multiply that together. So what's 4 times 2? 8 times 2x plus 3 cubed. All right, now we're going to go to the second derivative. The good news is I didn't create a product rule or anything, so it's pretty simple. You want a chain rule like this, okay? If you've got to go to second derivative. Okay, where's the 3 go? To the front. 3 times 8 is 24 times 2x plus 3 to the second. I still have a chain rule in there, so what's the derivative of 2x plus 3 again? 2, and then probably you're going to have to simplify because it is multiple choice, so 48 times 2x plus 3 squared. It looks like it's choice E. Yep. And you'll notice this year, actually I think it was last year on AP Calc, they went from 5 answer choices to 4. So on the actual AP test, you only have 4 choices. Ours all still have 5 because we're using old material. Okay? All right. That was 12. Oh, sorry, that was Gonzalo. Giselle, you get to pick the next one. 17? Okay. So 17 says that we have, what is the equation tangent to f of x equals 3x minus 5 cosine 2x, and we are at x equals 0. So we need the equation of a tangent line. What 2 things do we need for the tangent line? Point and slope. I don't really have either of those at this point, okay? To get the slope, what do we do? Derivative. So I'm going to evaluate the derivative at that point once I get the derivative, or at that x value. What's the derivative? 3x. 3. The derivative of 5 cosine 2x. What rule am I going to need? Chain rule, because we've got a function inside of a function. Anytime there's a number inside the trig, you're doing the chain rule. So I've got negative 5. What's the derivative of cosine? Negative sine. Notice I left space, right? Of 2x. And then what's the derivative of the 2x? 2. And I threw that up front. The double negative is going to go positive. Before I evaluate, I'm going to go ahead and simplify that. 3 plus 10 sine 2x. So f prime of x equals. Now I tell the grader, right, that I'm going to plug 0 in. We practice that even though it's multiple choice, because you don't want to not get in that bad habit. All right, so we've got 3 plus 10 sine 2 times 0 is what? 0. What is the sine of 0?
It's 10 negative 10 to 0.
0.
So that is 3.
So the slope is 3. Okay, so there's the slope of your line. I still need to find the y value of the point. How do I do that?
If you get to x and y,
I have x. Well, how do I get y?
plug x in.
Plug x in where? Into the original function. So I'm going to find, I left some space up there, f of 0 here. So 3 times 0 minus 5 cosine of 2 times 0. Okay, so we know that that goes to 0. What's cosine of 0? 1. So I've got negative 5 times 1, which is just negative 5. So my point that I have is 0, negative 5. All right, we got to put it into point slope, and it looks like we're going to have to make it into slope intercept, right? So y minus, what's your y value? Negative 5 equals, what's the slope? 3 times x minus 0. So I really just have a 3x on the right side. Double negative is going to go positive. I am going to move the 5 over by subtracting. So it looks like it is D, right? Everybody okay with that one? Yeah, what's wrong?
So whenever there's coefficient inside the cosine, the tangent, right? It's chain rule.
Yes. Every time, because that's a function inside of a function where your trig is your outer function and the algebraic piece is your inner function. Okay. Evangelique, which one do you want to see? 7. Okay, Lee, you're going to be next, so make sure you know which one you want, okay? All right, so number 7. Let me find number 7. It says we've got to find dy dx at 1, and our y is this lovely function. It's actually a quotient rule that's inside of a function. So it's the quotient rule is the inner function to the 4th power. All right, so I have to do a chain rule with a quotient rule inside. The good news is I don't have to simplify anything because I'm just going to plug a 1 into it. Okay? So my outer function, what do I do with this for?
Move to the front.
Move it to the front. So we've got y prime equals 4 times x cubed minus 2 over 2x to the 5th minus 1 to the?
Squared.
Nope.
Cube.
Cubed. All right, now we're going to do a quotient rule here. Okay, low d high. So 2x to the 5th minus 1. The derivative of the high is what? 3x squared. Minus, that was low d high. Minus the high. Derivative of the low, which is 10x to the 4th all over the low squared. The good news is I just have to plug a 1 in for all those x's. Okay, so we're going to find y prime of 1. So 4, what's 1 cubed? 1 minus 2 is? Negative 1. Can you shut that, CJ? Let's see. 1 to the 5th is 1 times 2 is 2. 2 minus 1 is? 1. All right, so we didn't get a whole lot out of that. All right, we're plugging a 1 into this thing. We already said that it's going to be what? 1. What's our entire denominator? 1 squared is still going to be 1. All right. What is 1 squared's 1? 3 times 1 is 3. 1 cubed is 1 minus 2 is negative 1. And then it's going to be, what's 1 times 10? 10. That's going to go what? Positive. All right, so let's see what's going on still. We have, I see a negative 4 times 13. Is that right? All right, so that gives us a negative what? Is it 52? That's one of the choices, thank goodness.
Negative what?
How'd I get negative 4? Because I multiplied 4 times negative 1. Okay. Everybody good? All right. Lee, you're up. Caesar Flores, you're next. Okay. So Lee, what do you want? Number 14. All right. So number 14, we've got a spherical balloon, right? So, oh no, a snowball. Sorry, a spherical snowball, diameter 4 inches. So the diameter is 4 inches. Removed from a freezer in June. It begins melting uniformly. This must be what kids in the Midwest do for fun.
Yes.
All right, and begins melting uniformly such that it is shrinking 2 cubic inches per minute. Okay, so it says 2 inches cubed per minute. What's that related to when it's cubed? Volume. So that's your dV/dt. Okay. How fast in square inches per minute is the surface area decreasing when the radius is 1 inch? Oh boy. Let me see if I have it on the other one. This one was 14.
Yep.
I did the work on the other one. No, I didn't. Okay. How fast? So they're wanting us to find dA dt, right? Because they're talking about the area when the radius is decreasing when the radius, so at that moment radius equals 1. Sorry, I used a parentheses instead of a quotes. All right, so first of all, I need the volume of a sphere. I believe it is 4/3 pi r cubed. Okay, whereas the surface area, I want to say the surface area is 4 pi r, no, that's a circle, I think. Look in the, somebody search it on the internet what the surface area of a sphere is real quick, okay? Help us out. I'm pretty sure that's the volume. All right, so we got to do dV/dt, right? Did they give me a rate for the, they only gave me, yeah, so that's the area, right? That's surface area. Double check volume real quick, okay? I like how we have a computer in front of us and Amador used his phone. So, okay, that's awesome. Okay, so dV/dt, am I right? Okay, that was good that I remember both of those. All right, so we got to take this and put it where? So I've got 3 times 4/3 pi r squared dr dt. Okay, so what happens with these guys right here? They cancel. The radius at that moment is 1. So I've got 4 pi times 1 dr dt, and it gave me that dV/dt is what? 2. But it says it's shrinking. I missed something. Shrinking would make it what? Negative. So you have to watch that. You kind of have to read that in the context of the problem. So really over here, don't I just have 4 pi dr dt? I need to take this and get it to the other side. How do I do that? Divide it. So I'm dividing by 4 pi, which would reduce to 1 over 2 pi. But look at what they're asking us to find. They wanted us to find the rate of the area. We have dr dt. So I'm going to have to take the derivative of this and plug into that. So dA dt, this is what made it the AP level question right here. Okay. I'm going to take this and move it to the front. What do we get?
8 pi r dr dt.
8 pi r and then dr dt.
Which we found out was -1.
Yep.
2 pi.
So we have, for r we said it was 1, and for dr dt we calculated the -1 over 2 pi. Oh boy, what happens with the pi's? They cancel, so what do we get?
4. Negative 4, excuse me.
Oh, we have a 2 there too, don't we?
Yeah.
So -4. Is that one of our choices? Yep. Oh no, it's not. What happened? It was. We probably made a sign mistake somewhere. How fast? Oh, okay. Do you see what it's saying? How fast is it decreasing? So it put a double negative in there. This is the rate it's decreasing, but it gets the double negative. It's probably meaning like it's doing. We would have had a negative there and divided it over. That's weird in the wording. Okay, it's a horrible problem. You think not to put that one on the test? All right, we'll see.
Oh, what the blood?
Okay. Evangelique wants it on the test.
I don't.
Okay. All right, Caesar, you're up. David, you're next. 4? Okay. All right. Oh, boy, look at that one. That one looks fun. Okay, so we've got f of x equals the square root of 1 plus the square root of x. So we've got like a massive chain rule in there. So I'm going to rewrite this as 1 plus x to the 1/2 to the 1/2. Doesn't that look better? Even though it's got fractions, you bet you never thought something with fractions would look better. All right, so now it's really easy to tell the outer function and the inner function, right? So this one's outside. Where does it go? In the front. So 1/2, 1 plus x to the 1/2 to the, when I subtract 1 or 2 over 2 off of it, what do I get? Negative 1/2. Okay. Now I need to do the chain rule. So I need the derivative of the inside. So the derivative 1 is 0. What's the derivative of x to the 1/2? To the negative 1/2, right? Because I have to subtract the 2 over 2 off of that for the chain rule. Okay, so now let's figure out where everything is at. Because look at what the numerator should be. It should be either a 1 or a negative 1. So the 2 is already hanging out in the denominator on both of them. So what's 2 times 2? 4. This is indicating I need to take it downstairs and convert it back into what? Look at your answers. What do I have to convert back to? A square root. So this is saying I've got the square root of 1 plus the square root of x. This is saying I have another square root of x. All right, so let's see. It looks like they wrote it in the other direction, right? They wrote it 4 square root of x, square root of 1 plus square root of x. So it's looking like choice D, is that right?
Yeah.
Yeah. Because we have the positive one, not the negative one. All right. David, you're up. Amador, you're next. 16. Is that right? Okay. Oh, that's a good one too. We love the chart problem. Okay. All right. Selected function and derivative values for the differentiable functions f and g are given in the table above. If p of x equals x times f of x minus g of 3x minus 2, then they want us to find p prime of 2. So I need to take the derivative of this thing first. I have a product rule and a chain rule over here. Okay, so watch how this happens. So I'm going to keep the first, take the derivative of the second, which would be f prime of x, plus keep the second, which is f of x. What's the derivative of x? 1. I'm going to write it in there so we know what's going on. Okay. Now I need to take the derivative of this thing here. So the derivative of g would be g prime of this function. And then I need to take the derivative of the function in the inside, which is going to get us what? 3. What am I going to plug in now? 2. So I have 2 times f prime of 2. I probably have too many parentheses there. Plus f of 2 minus, let's see, what's 3 times 2? 6 minus 2 is 4, and then times 3. To get these numbers, that's what the chart is for. So, looking in your chart, I'm looking for f of 2, which looks like is that number right there. So what is that? 5. Oh, I'm sorry. CJ's right. F prime of 2, which is 1. Make sure you're reading your chart right. Okay, because it'll mess it up. I bet that answer is there, though. All right, f of 2 is 5 minus, we need g prime of 4. What do we get there? Negative 1 times the 3. What's negative times the negative? Positive. All right, let's see if we can add this together. So what looks like 2 plus 5 plus 3. 10. It's not a bad, it's actually a good problem. I actually like these. Okay? But you have to get used to reading the information out of the chart. Okay? All right, Amador, you're up. And if you guys want to stay for one extra, Bethany has the last one. Okay? So Amador, which one do you want? 18. Okay. All right, so 18, we can do, it's the sine of xy equals x plus y. They want us to find dy dx. So, first of all, what's the derivative of sine? Cosine xy, and then I need to do the chain rule. So the chain rule has a product rule embedded in it. So keep the first. What's the derivative of the second?
dy dx.
Plus, keep the second, which is y. What's the derivative of the first?
Dx,
dx or 1. All right, now I got to take the derivative of x, which is dx dx or 1. What's the derivative of y? dy dx. Okay, now I have to start moving stuff around. I'm going to choose to... let's see how they do this one. I think we have to distribute this in, actually. Because look how they've got a cosine on the top and the bottom. So I've got x cosine xy dy dx plus y cosine xy equals 1 plus dy dx. So it's algebra more than calculus on this one. That's usually where we lose it, is the algebra. All right, I'm going to move the dy dx to the other side by doing what? Subtracting it. And I'm going to move this y cosine over by subtracting as well. Y cosine xy. All right. I'm going to take out a dy dx. Oops. Not equals, parentheses. X cosine xy minus 1 equals 1 minus y cosine xy. And then what am I going to do to get this to the other side? Divide it. Bethany, do you have one that you want to see? Number 9? Okay. X cosine xy minus 1. All right, I'm going to go to number 9 real quick, and then we will go. Okay? All right, so number 9, is that a ladder? Is it a ladder problem? Yeah. Okay, so 20-foot ladder slides down the wall. So you've got a ladder, it's 20 feet. Slides down a wall. I better label my x and my y. So down a wall is dy dx, right? Or dy dt. At 5 feet per second. It's going down the wall, so isn't my rate negative? Yep. Okay, you got to watch your direction. At what speed is the bottom sliding out when the top is 10 feet from the floor? So the top, it's saying at that moment top is 10. It wants to know the rate of the bottom. Okay? So we're going to use Pythagorean Theorem. X squared plus y squared equals 20. What's the derivative of x squared with respect to time? 2x dx dt plus 2y dy dt equals 0. All right, we're going to put I'm going to put x in. What's my, at that moment x, what would I have to do? I'd have to do Pythagorean Theorem, right? I'm going to tell you, and in the interest of time, that it is the square root of 300. Okay? I actually have work on this one, believe it or not. So 2 square root of 300, dx dt, I don't know, that's what I'm trying to find, plus 2. The y at that moment is 10. dy dt is negative 5 equals 0. When you actually do all of the work, the dx dt ends up being 100 divided by 2 squared of 300, which the decimal point. So if we did this one, it would be a calculator problem. Okay? All right. We will do office hours Monday. We'll see how much interest BC has, and then I'll let you know what time, okay? Plan on it being evening time. All right? I will send out a text. If you're planning on helping, I still need helpers for... You're going to be the 5? Okay. And then I need Saturday helpers. If you can sign up, I need them by noon. If not, I'll have to cancel. I know Giselle was going to do early morning. Are you still able to do early morning Saturday? Okay, and you know where to go? So basically what I'm going to have to do is I'm going to have to drop a coolers off because we have a soccer game at 9. And we have to be there at 8:30.
Yeah,
So
I'll
you're
be
going to
there at
basically be
7.
in charge. Okay.
So
So
I'll be there.
so you'll be there to, and so
Yeah.
you'll figure out where the coolers are. If you could meet me out in front of the school like at 8,
Okay.
we'll be there right at 8.
Okay.
And then we'll push the coolers back to wherever they need to go. And basically you get to babysit the coolers and
Cool.
sell drinks. I'm going to have the little one.
Right.
And so I'm going to put all the sodas in that one, and because I don't think we're going to sell much soda, and then I'll put all the
Yeah.
Gatorade and water in that one.
Okay.
Okay? And by tomorrow, it'll probably just be ice water, but in there with it. But that's okay. It'll still be cold. Okay. I'll let you know if I'll put out the text if we cancel. Okay? Well, I appreciate you doing the 8 o'clock. At least we had one person to sit with it.